Hey guys, welcome back to another podcast. Today we're going to be talking about is AI the future of medicine?
So, I think it's important to clarify what exactly AI is. So, AI stands for artificial intelligence, as I'm sure many of you knew. But what exactly is it? Well, it refers to the stimulation of human intelligence in machines that are programmed to think like humans and mimic their actions. The term can also be applied to many machines that exhibit traits associated with the human mind, such as learning and perhaps even problem solving. There is a certain pre-existing myth surrounding AI that it's extremely futuristic and complex, but some real-world current examples of AI, which are part of everyday life, are things such as ride-sharing apps. My mind immediately goes to Uber, Lyft, and more. Spam filters in your email inbox, AI email categorization, even plagiarism checkers, and AI also covers virtual assistants like Amazon's Alexa, Siri, Google Assistant, and any others you may know of. So AI has been and will no doubt continue to be present in many aspects of our lives for
Yeah.
to come. Four key types of AI, which are there are four key types of AI, which are reactive machines, limited memory, theory of mind, and self-awareness. The most common are limited memory and reactive machines, with reactive being purely able to react to a given situation or phrase, and limited memory machines being able to look slightly into the past transiently, but they don't actually store the memory. The other two types of AI included theory of mind and self awareness, and those are the more sci-fi like futuristic versions of AI. With theory of mind being the ability to develop human-like mental capacity and have emotional intelligence, thinking capacity, creativity, reason, logic, and everything else associated with the human brain, and self-awareness being the stage at which machines have consciousness and form images of themselves. And this is a stage which is further away right now. But my question is, what's an example of AI in medicine? I've heard of a few like Microsoft's in AI. Does anyone know more?
Yeah, so Microsoft in eye. So there's a hospital called Addenbrooke's Hospital in Cambridge, and they're going to become the first hospital in the world to use AI technology from Microsoft, and it's meant to improve survival rates for cancer specifically. So the Inner Eye project, like you said, it develops AI models that use the hospital's own data to automatically highlight tumors and healthy organs from patient scans. So these will be checked and confirmed by clinical oncologists before the patient receives treatment. Of course, it's a new technology, so there could be some risks to it, but it will shorten the lengthy treatment planning stage, which is critical for cancers of the head, neck, which can grow fast if left untreated. Experts are expecting survival rates to increase. So the results from the inner eye are basically a game changer. To be diagnosed with a tumor of any kind is incredibly traumatic for any patient. So as clinicians, they want to start radiotherapy promptly to improve survival rates and reduce anxiety. Using machine learning tools can save time for busy clinicians and help get the patients into treatment as quickly as possible. So the process is basically starting with a 3D CT, a computed tomography imaging scan of the part of the body to be targeted. Then these images come in the 2D form, uh, dozens of images deep, each of which has to be examined and marked up by a radiation oncologist. The process is called contouring. So in each image, an expert must manually draw a contour line around the tumors and key healthy organs in the target area using dedicated computer software. So for complex cases, this can take several hours in the planning of a single patient's treatment. But inner eye can do this task 13 times faster, hopefully. The Addenbrooks has been working with Microsoft to develop and pilot in AI over the past 8 years or so. And when the AI tool is in place, hospitals will be able to use its own data to improve its own accuracy. It's believed to be the first time an NHS trust has introduced a deep learning solution trained on their own data. Obviously, there's major concerns surrounding the relationship between the patients and their doctors specifically. The consultant clinical oncologist at Adam Brooks said, but it's important for patients to know that the AI is helping me in my professional role. It's not replacing me in the process. I double check everything the AI does. I can change it if I need to. The key thing is that most of the time I don't need to change anything. I think that's the key point. The relationship is probably the most stressful thing that the patient will uncover when it comes to being introduced to new AI technology. It's all about the patient's care in the hospital. So their psychological effect by having this new tech around them, it has to be balanced. I know this is just one type of AI technology. I know there's something called heart flows AI technology?
Yeah, so the heart flow analysis starts when a patient undergoes standard coronary computed tomography, which is known as a CT scan, at a hospital or an imaging center. And the
Hmm.
CT scans are securely uploaded to their cloud. And then they use advanced algorithms, which incorporates artificial intelligence within it to build a personalized digital model of the patient's coronary arteries, and then their analysts inspect the model and make any needed edits. So once the patient-specific model is completed, the heart flow process applies physiological principles and computational fluid dynamics to compute the blood flow and the FFRCT values at every point in the model. Throughout the process, they follow rigorous and well-established protocols to ensure that there's consistent processing for every patient, no matter which site the data comes from. So I think this one has the potential to really change the way that we use and identify coronary heart disease, because by using computational models, we don't need to use cath labs or invasive technology to really understand how and where the problem lies within our heart. So I did a stint of work experience in a cath lab, and they have to make a small incision in the vein of a patient and put a small nanotech camera all the way into the heart through the vein from the arm. And this is quite a lengthy, long process, and it can be really hard to see what's going on sometimes because the X-rays can't penetrate fat too well, and that's why this sort of technology will really change the way that we diagnose and treat coronary heart disease. I mean, there are also other applications that I've heard about, like Cedar Science. What
Yeah,
about that one?
yeah. So the Cedar Science app, which is just to clear up, spelled with the letter C as opposed to the word. It's a really interesting new app developed by doctors and researchers at King's College London. So it's founded by King's Medicine alumna Dr. Bhavagaya Bakshi and co-founder Dr. Miles Paling. Cedar Science is essentially working with the NHS to help identify patients who are at risk of developing cancer at the earliest and most curable stages of disease. And how it works is an online tool for GPs, which has only recently been implemented. implemented, sorry. So the reason for its need is because 50% of patients are diagnosed with cancer in its last stages of growth. As a result, 80% of those patients will die within 5 years. If there were to be an earlier diagnosis, 80% of patients would thus survive 5 more years. Cedar Science enables you to detect cancers earlier and thus can help increase the life expectancy of patients diagnosed with cancer, and perhaps even their chance of recovering. So, as those stats show, early diagnosis of cancer is vital for increasing the chance of recovery and successful treatment, as I just mentioned. Um, Diagnosis is an extremely difficult thing to do with cancer. Unlike other conditions, there's no single symptom that can alert clinicians to a potential cancer diagnosis. And there's also no single test or investigation which necessarily gives a 100% accurate result, as there is for some other stuff. We've mentioned cancers in previous podcasts, so definitely go and listen to those. But there's no one single test which gives a 100% success and accuracy rate, is what I'm alluding to. So um, the reason Cedar Science is so unique is because um, it can it can cover an entire spectrum of cancers, and that supports doctors in identifying the risks and which cancer and which possible other cancers a patient could have. Doctors can search by systems like chest or gastro, or by individual signs and symptoms or risk factors such as thrombocytosis or weight loss. Information is entered into the tool, and that's then cross-checked against all cancer pathways, and that highlights when patients are at greater risk of multiplying of having multiple cancers. So, like I mentioned, with the difficulty with cancer, it's often vague and non-specific and can overlap with less sinister conditions, which is very difficult to identify and kind of narrow down to a specific cancer. So Cedar Science really helps with that aspect, with you being able to enter all symptoms and then giving an actual value of how likely is the patient has cancer and what their risk is of multiple cancers. Um, I see it being highly influential with cancer being such a huge issue, and I really see it fulfilling its potential. Cedar Science uses advanced algorithms and combines those with optimization and prioritization systems to reflect the natural decision-making process of doctors, and then translates complex research and guidelines into a simple and intuitive journey for the user, so it maps out a path for the patient to recover, which is also another unique feature which helps a patient know what the steps are going to be in their treatment. And I think that's what makes it so unique, personally. But that was just a brief overview of it. But does anyone know anything about Google's medical AI or Google's DeepMind?
Yeah, so DeepMind Technologies is a British artificial intelligence subsidiary of Alphabet Incorporated and research laboratory founded in September 2010. So DeepMind was acquired by Google in 2014, and the company is based in London with research centers in Canada, France, and the United States. So in 2015, it became a completely owned subsidiary of Alphabet Incorporated, and that's Google's parent company. So DeepMind has created a neural network that learns how to play video games in a fashion similar to that of humans, as well as a neural Turing machine, or a neural network that may be able to access an external memory like a conventional Turing machine, resulting in a computer that mimics the short-term memory of the human brain. So the applications of this are yet to be discovered, but it's essentially it could help in for dementia and other sort of neurological disorders that results in the decline of the human memory and the short-term memory loss as well. So, I mean, what about other projects being worked on for the future? So these are the ones that are currently around, but aren't the NHS trying to push to get more projects for artificial intelligence within their services?
I think it's obvious there's going to be a lot of new projects surrounding the AI technology. I mean, we can all certainly agree AI is going to take over and be the foundation for a lot of new technologies we're going to see in the up and coming years, especially actually in the healthcare industry. I mean, I reviewed through the list of projects funded through the AI in Health and Care Award. There's already an award set up for it. I mean, they were put into phases 1 to 3 and then phase 4. So phases 1 to 3 aim to create a pipeline of products, interventions, and services which are ready for wider testing. And then we have phase 4, which is meant to identify medium stage AI technologies that have market authorization, but not enough evidence to give them large scale commissioning or deployment. So there's an example of each stage I've got written down. Phase 1, Project Rhapsody by Novoic Limited. So it's investigating the clinical feasibility of using AI-based deep audio and language processing techniques to diagnose neurological diseases. So in essence, the AI technology gives, I guess, a novel way to analyze complex speech language patterns from free speech to detect common neurological diseases. And a key differentiator that I found was the use of proprietary speech representation methods to build generalizability. Then in phase 2, we have Breathe OX Limited talking about prediction and prevention of asthma attacks in children. Albus Health have developed a small tabletop device that can automatically monitor a range of symptoms and metrics without patients having to do or wear anything, helping to predict preventable asthma attacks in children. I think the most common feature amongst all these new AI technologies is self-diagnosis and self-awareness rather than having to rush to the hospital and seek medical attention immediately from all these busy doctors
Yeah,
and clinicians. I think that's a great way to move forward. It's interesting to think how AI will make it work, but all these apps and such. So there's another one in phase 3, smartphone albuminuria self-testing by healthy.io. So it's basically a home test kit and mobile app. And their solution empowers patients to self-test at home with clinical grade results. Like that's amazing. Think about it. Doctors going to so much schooling and education, you just having one app to just do at home. It's much more
yeah,
convenient as well.
it
It's
is.
fully
And I think that
integrated.
the accessibility of AI is the one thing that makes it very alluring for or all sectors, not just medicine. And it's quite
Exactly.
easily
There's
accessible.
the shifting testing to home literally increases uptake, improves the quality, it reduces workload in primary care, and it creates savings as well.
Yeah, I
It's
agree.
real-time results and they're available for clinician review and follow-up as well. So there's a lot of new tech coming that aims to be very beneficial, and to me, it sounds very beneficial. But obviously, we have to talk about the ethics of AI and how it's being implemented. What we have to talk about the medical ethics, right?
Yes. So artificial intelligence is quite a difficult topic to have ethical papers on, because it's something that not all people understand, essentially. And I'll come on to that a bit later. But in terms of the medical ethics pillars, beneficence is the easiest medical ethic pillar that we can enforce using AI. So the principle of AI is to benefit the human race, essentially. And all the 6 papers that write about artificial intelligence ethics agree that the key objective is using it to benefit the well-being of the human race or the common good. And in the House of Lords, in the House of Lords annual AI report, it is described that AI should be developed for the common good and the benefit of humanity. So we can see that there's very little ethical issues in terms of beneficence, because the whole reason of developing artificial intelligence is to benefit the human race. And I think that's why it's probably the easiest medical ethics pillar to enforce compared to the other ones. So, I mean, what about non-maleficence? I mean, that's kind of the sister of beneficence, but how is it different, or is it the same?
I mean, with non-maleficence perspective, the perspective is quite simple. Non-maleficence is the principle that a doctor should never harm or endanger a patient knowingly without there being good reasons, such as requiring life-saving treatment, which may cause harm, etc. But so long as the AI implemented does not pose serious harm to a patient and is only implemented for the good of the patient, I see no way in which the pillar of non-maleficence is in violation. The only way to avoid this, as stupid as it may be, is to really check the AI and make sure that there are no menial commands put in place which may force AI to alter the course of the patient's treatment when it's not required, which could then have negative outcomes. It's also important that the data set being used for these potential AI must be ones with appropriate structure and reliability and human likeness. This comes most into play in regions such as intensive care and other vital regions of a hospital and of care of patients, and potentially even like palliative care, all of those. Thus, many people have suggested that when implementing AI, we have a barrier of sorts where AI is implemented for menial tasks with no life-altering decisions and no huge reactions to be made or decisions to be made, and is only put in place where, such as in, for example, the Cedar Science app, in assisting clinicians and physicians. But what about the other pillars? Justice, all of those?
The principle of justice deals with the distribution of resources within a society and the non-discrimination of individuals. But non-intentional injustice has become an important issue for AI. So it's ranking algorithms. That's part of the major concern when it comes to talking about application. So there's a lot of scenarios they have to take into account. Cultural biases that have been ingrained from social or professional frameworks in a specific environment. You have to think about modifying to incorporate environmental characteristics. Then there's the worry that algorithms may assign a low chance of survival to previously disadvantaged patient groups. So we can say discriminatory biomarkers like body weight.
With regards autonomy, which is obviously the fourth medical ethics pillar, when designing and implementing AI solutions, the human in the loop process must be incorporated to ensure judgment and decision making in relation to patient care is accommodated.
Yeah.
So the patient's history, findings, and preferences following conversation between patient and healthcare provider should be factored in, obviously, right? So patient patients should be able to maintain autonomy and understand how the AI solutions are being used for their care in decision making. So in general autonomy, when we're expressing as doctors, if we're expressing how a certain treatment is going to go down to a patient and their treatment options, they have full autonomy to decide which treatment option they should choose or should they accept one at all. Equally, an AI would be required to explain in the same detail the treatment options and react to the request for treatment that a patient gives in the same way as a human would for it to be successfully implemented. So perhaps a suitable solution would be to create a method by which a patient can decide whether they would like to have AI involved in their treatment or not in the first place, and that's the first point of autonomy. And should the patient opt in, then AI can potentially be used as an aid to doctors, as seen with the C-Science tool. I think furthermore, from the perspective of autonomy, a big issue is that an AI may lack the potential to explain a treatment plan, which I was talking about, to patients in the same way as a human doctor can. So while it's important that that happens, it's very difficult for an AI to explain things in the same way. So obviously the way code works, it can only react to a set amount and a limited amount of responses. So should a patient ask a question which a human could answer flawlessly, an AI may struggle. And I think that's why AI may have a lot more development that's required prior to it being implemented in clinical use. I think it. I think it is fairly there's a fair amount of potential in the sense that should those barriers of offering patient autonomy and stuff be overcome, then yes, it should definitely be used. But I think those are huge points because autonomy is one of the crucial points of care for a patient. They should always have the right to choose what treatment they desire and understand how that's going to affect them. So should that at any point be taken away, I don't think AI should be implemented. There's also certain issues between non-maleficence and autonomy. Should an AI decide that the treatment would require a harmful approach, so a doctor may be able to explain a treatment and someone opt out of it, whereas with an AI, if it chooses a decision, if it chooses a treatment pathway which involves a somewhat harmful approach, which a patient may normally agree to, but in this case may have not. I think there's that kind of paradox because now the AI isn't acting in accordance with non-maleficence, whereas a doctor would. So I think it does definitely requires much more research. But yeah, are there any other viewpoints to consider, perhaps?
So all of these medical ethics pillars raise the point of explicability. So explicability, in its essence, is how to explain it would probably be better if I give you an example. So a small number of scientists develop AI to benefit the wide human race. So this sort of power clearly makes it unequal. The scientists have got a lot more power than the general public in terms of knowledge and applicability for the AI technology. So it's important to understanding how AI works and who is responsible for the way it works, which can be known as intelligibility and accountability. And there is a need for transparency to the general public and not just a small number of experts. And this comes in line with the four medical pillars, as we know how and why AI will act, and in the event of a serious negative outcome, who to hold accountable to prevent this from occurring. It's a little confusing, but it's the main concept that we should understand how AI works so that we know what to do when there's a serious negative outcome. And we should also know why it acts in that way and who programmed it, so we know who to hold accountable in case of a problem. I think that was what explicability is.
Yeah, I think that was
quite brief.
I think that's quite well put. Obviously, it requires a bit more detail generally, but I think that we provided a good overview of the ethical perspective. I think it's a conversation that has a lot more depth that we could cover, but generally, I feel as though there's no major ethical objections to the use of AI, so long as the key ethical pillars such as non-maleficence, beneficence, and autonomy, as well as of course justice, are upheld throughout the process. I think generally AI with more research and more detail into the and more detailed research into the fundamental code and data sets of the AI could have huge potential to impact medicine. We see already with AI such as Cedar Science and Microsoft's InnerEye that there's so much potential, and I think that will only continue to grow over the coming years. But I think the site of most potential is as an aid and as an aid to doctors and clinicians as opposed to a replacement. But yeah, I think that summarizes today's.
Thank you very much for listening to our podcast today. It's a little bit different and a little bit of a future potential podcast rather than something that isn't a here and now. But thank you for listening, and please subscribe to support the channel. It really means a lot. And please like this video as well. Please make sure you follow our Instagram handle to get upcoming podcasts and fun facts and more. And also subscribe to the Twitter handle as well.